So for the last session, we have started our module, pure substances. Right. So what is pure substance? It is a particular substance which satisfies three conditions: homogeneous in composition, homogeneous in chemical aggregation, and invariable in chemical aggregation. Yesterday I had told you about what is the particular three satisfying conditions: what is composition, what is homogeneous, and what is chemical aggregation. What is chemical invariable in chemical aggregation. So thereafter phase transformation. So we had draw a PV diagram. As I said that there are PV diagram, PT diagram, HS diagram, TS diagram, and so many diagrams in a particular module. സോ ഒന്നും വൃത്തിക്കൊന്നും ഇതുപോലെ പഠിച്ചു കഴിഞ്ഞാൽ സിമ്പിളാണ്. ഓരോ ഫിഗറും ഇതേപോലെ നോക്കി അതിൻ്റെ ടെക്സ്റ്റ് ബുക്ക് നോക്കിയിട്ട് അതെന്താണ് പറഞ്ഞേക്കുന്നത് വായിച്ചിട്ട് ഫിഗറും കൂടി നോക്കി മനസ്സിലാക്കി കഴിഞ്ഞാൽ ഇറ്റ് ഈസ് വെരി സിമ്പിൾ. So yesterday we had drawn the particular PV diagram. So PV diagram we had drawn a particular water particular vaporization technique. The phase transformation of liquid into water we had drawn here. So already I drawn a doom, and thereafter it is we are taking a particular temperature. We are taking a temperature 20 degrees Celsius 1 kilogram of mass. When you have started heating it and it is a particular temperature, it means that 100 degrees Celsius and the liquid boil. So initially when 0 to 100 is a particular state, 0 to 100 is happening. So it is increase in temperature to 0 to 100. Thereafter boiling takes place at 100 degrees Celsius and the saturation temperature. And when the vaporization takes place, the temperature is known as vaporization. It is known as saturation temperature, and pressure at that point is known as saturation pressure. Okay, then the liquid is transformed into vapor from this point to this point slowly at atmospheric pressure. And thereafter, when it reaches to point 3, the whole liquid changes to water. Whole liquid changes to vapor. And at saturation temperature, the level is saturation. The level we can draw if it is a P pressure is denoted by the y-axis. If the x-axis and at a particular the figure correct line ആയിരിക്കുന്നില്ല, കുറച്ച് ചെരിഞ്ഞിട്ടായിരിക്കും ചിലപ്പോൾ ഉണ്ടാവുക. So we can say that it is a constant temperature, saturation temperature, constant temperature level process is happening in the particular vaporization process. അവിടെ 2 to 3. That is a lengthy procedure from 2 to 3 at saturation temperature. Okay, and thereafter whole liquid changes to vapor, and we are heating the particular vapor, and the vapor changes to superheated vapor, 3 to 4 superheated vapor, and the temperature at the particular level is known as superheated temperature, which means that temperature above the saturation temperature. And the again process we are doing the present is various pressure level. It is an atmosphere pressure level. When we are increasing pressure level and we are particularly doing this procedure here 5, 6, 7, 8, we will get a similar graph, similar diagram. So it is the condition of formation of steam or formation of vapor, right? So 6 to 7 procedure, when we are increasing pressure, the length of the vaporization line goes on decreasing when we are increasing pressure, moving up. And when a particular level occur, there is it hits the particular top portion of the particular graph, that is critical point. And at that point, a temperature is known as critical temperature, pressure is known as critical pressure, and there is no vaporization line here. There is no vaporization, only a point. The particular liquid touches the point and simply changes to superheated vapor. And above the critical point, there is no vaporization curve here. Simply as liquid is directly transformed into superheated vapor. No saturation point is. Okay, this is a particular figure PV diagram of water. ഒരുപാട് പ്രോസസ്സിനും വേറെ ഇപ്പം വാട്ടറാണ് എടുത്തത്, വേറെ എന്തെങ്കിലും ചേഞ്ച് ആണെങ്കിൽ അതിനൊക്കെ വേറെ ഫിഗർ ഉണ്ടാവും. നമ്മൾ ബേസിക്കലി വി ആർ സ്റ്റഡിങ് ഹോൾ ഗ്രാഗം ബേസിക് ഓഫ് വാട്ടറിനെ ബേസ് ചെയ്തിട്ടാണ് പഠിക്കുന്നത്. ഓക്കെ, ദ പ്രോപ്പർട്ടീസ് വി ആർ സ്റ്റഡിങ് റിലേറ്റഡ് ടു വാട്ടർ, ഫോർമേഷൻ ഓഫ് സ്റ്റീം, വാട്ടർ. Okay, so that was the particular I studied yesterday. So from here we are studying about some phase change properties and terminologies. Phase change properties and terminologies. We know that there are three phases we are describing normally, that is liquid, solid, and gas. Liquid, solid, and gas. Or gas എന്ന് പറയാൻ പറ്റില്ല. What is gas? What is the difference between gas and vapor? We cannot say vapor is equal to gas. It is not. vapor gas and the gas of oxygen, ethane, methane. Vapor is a simple formation of H2 and O. H2 and O. Okay, when the liquid boils, the particular liquid changes to vapor. That particular vapor is not as same as gas. When we had drawn yesterday, we had drawn this figure, and this formation here, the formation of vapor is happening here. And when the temperature increases above the particular saturation temperature, the vapor changes to superheated vapor. Right? That particular superheated vapor is termed as, and above the critical point, in upper point വേപ്പറിനെ പറയുന്ന പേരാണ് പർട്ടിക്കുലർ ക്രിട്ടിക്കൽ പോയിന്റ് മുകളിൽ വരുന്ന വേപ്പറിനെ പറയുന്ന പേരാണ് ഗ്യാസ്. ഓക്കെ, സോ അപ്പോൾ വി ഹാവ് ത്രീ ദാറ്റ് പർട്ടിക്കുലർ ഫേസ്, ദാറ്റ് ഈസ് solid, liquid and vapor is S, L and V. So solid, liquid and vapor are the three properties we are taking for under consideration. So for solid we are using the prefix. When he has seen anything VF, VG, VH, VFG, HFG, HG എന്നൊക്കെ ഒരുപാട് ടേമുകളാണ് ഈ മൊഡ്യൂൾ നമുക്ക് വരുന്നത്. There are many terms related to something suffixes VF, VI, VG, VI എന്നൊക്കെ പറഞ്ഞിട്ട്. So what is the term relating I, F and G? I, what is I and what is F and what is G? You want to know it. So we are representing suffix, any suffix from volume of I എന്ന് പറയുന്നത്. അപ്പോൾ suffix ആണ് I എന്ന് പറയുന്നത്. So suffixes. So we are using suffixes for solid as I. In this module we are using solid as I suffix, liquid as F, vapor as G. This vapor is converted into G gas in form like മനസ്സിലാക്കിയാൽ മതി. Liquid fusion fluid take F and solid I. Okay, IFG. That is a terminology for suffixes of solid, liquid and vapor. And what is the phase change properties? Phase change properties or phase change suffixes we are using. Phase change properties means phase change we can take three stages, that is solid to liquid. Solid to liquid is a particular fusion phase change. Fusion that happening is fusion. Solid to vapor is sublimation. And liquid to vapor, liquid vapor interface we are known as vaporization or evaporation. Right? Liquid vapor on the process evaporation, solid vapor on the sublimation, and solid to liquid fusion. Okay, so you can name that particular procedures as fusion, sublimation and evaporation. Okay, and the particular process happening, the particular then the process happening in the condition we can take it as freezing or melting. Freezing or melting process is happening in the case of liquid changes to liquid. Solid changes to liquid ആകുമ്പോഴാണ് melting process happening. Solid is melting to liquid. And sublimation എന്താണ്? Frosting. Can take it as frosting. Frosted എന്ന് പറയുന്നത് frosting or defrosting. Third one, evaporating or condensing. Freezing means freezing happening when liquid changes to solid. Liquid solid ആയി മാറും. വെള്ളം നമ്മൾ ഐസ് കട്ടയാക്കി മാറ്റുന്നതാണ് ഫ്രീസിംഗ് എന്ന് പറയുന്നത്. ലിക്വിഡ് ടു സോളിഡ്, സോളിഡ് ലിക്വിഡ് ഫേസ് ചേഞ്ച് ആണ്. പ്രോസസ് രണ്ട് പ്രോസസ് നടക്കും, ഒന്ന് ഇങ്ങോട്ട് നടക്കും, ഒന്ന് അങ്ങോട്ട് നടക്കും. ഫസ്റ്റ് ചേഞ്ച് liquid to solid freezing and solid to liquid melting. And here solid to vapor, frosting and defrosting happening അങ്ങോട്ടും ഇങ്ങോട്ടും നടക്കുന്നു. And liquid to vapor is evaporating and vapor to liquid is condensing. Okay, suffixes we are using is suffixes for particular process solid to liquid interface we are using suffix as IF, solid liquid IF. Liquid vapor ആകുമ്പോൾ liquid vapor FG, liquid vapor FG, and solid vapor IG. Okay, when we either any name is happening, we are seeing that VFG, we can relate that the volume, a specific volume of liquid vapor interface or particular process happening from liquid and vapor. And VFG, evaporation or FG. Okay. Thereafter, we have studied many particular topics related to many related terms, terminology, and we are here in this session we are discussing about terminology and properties related to something that particular process. So here yesterday we have studied about critical point. Critical point എന്താണ് നമ്മൾ പഠിച്ചിട്ടുണ്ട്? critical point, critical pressure, and the particular at a particular critical point pressure is known, at the point pressure is known as critical pressure, temperature is known critical temperature. And gas, what is gas? Gas is a vapor whose temperature is greater than critical temperature. When the temperature goes on increasing above the critical temperature, the pressure ഒരു വേപ്പറിന്റെ പ്രഷർ അബോവ് ദി ക്രിട്ടിക്കൽ പ്രഷർ ആകുമ്പോൾ, അല്ലെങ്കിൽ ഒന്നിന്റെ ടെമ്പറേച്ചർ അബോവ് ക്രിട്ടിക്കൽ ടെമ്പറേച്ചർ ആകുമ്പോൾ വി ക്യാൻ കോൾ ഇറ്റ് ആസ് എ ഗ്യാസ്. ഓക്കെ, സോ വാട്ട് ഈസ് ഗ്യാസ് എന്ന് പറഞ്ഞാൽ, വാട്ട് ഈസ് ഡിഫറൻസ് ബിറ്റ്വീൻ ഗ്യാസ് ആൻഡ് വേപ്പർ എന്ന് പറഞ്ഞാൽ ഒറ്റ മറുപടി ഉള്ളൂ. ദ ഗ്യാസ് ഈസ് ദാറ്റ് gas is a particular vapor which the temperature of particular gas increases, or a vapor increases above the critical temperature. Okay, that is gas. So what is liquid vapor terms we have studied yesterday? That is saturation pressure. What is saturation pressure? Saturation pressure means at the pressure, a saturation pressure is the pressure at the when temperature is when temperature saturation temperature ആകുമ്പോൾ പ്രഷറിനെയാണ് saturation pressure എന്ന് പറയുന്നത്. When where the temperature happens to saturation pressure? At the time of vaporization. The time of vaporization, when temperature changes to saturation temperature, the pressure is known as saturation pressure. And what is saturation temperature? Vice versa. At the time of vaporization, when the pressure changes at a pressure, when a pressure is changes to a saturation pressure, we can call that particular temperature is, at that point temperature is known as saturation temperature. Vice versa. Okay, at the time of vaporization. At the time of vaporization, the temperature for liquid vapor is known as, the liquid is known as saturation temperature or saturation pressure. Okay, what is saturated vapor? What is saturated vapor? Saturated vapor or superheated vapor is that, right? At the vapor at the state of saturation temperature and pressure. At the state of saturation pressure and temperature, that vapor is known as saturation vapor. And when the temperature reaches above the saturation temperature, we can call it a superheated temperature and superheated vapor. ആ പോയിന്റിന് മുകളിൽ കാണുന്നതാണ്, അതായത് ഇവിടെയുള്ള വേപ്പറിനെയാണ് സാച്ചുറേഷൻ വേപ്പർ എന്ന് പറയുന്നത്. ഇതിന് മുകളിൽ പോയി കഴിഞ്ഞാൽ സൂപ്പർ ഹീറ്റഡ് വേപ്പർ. That is super saturation vapor and superheated vapor. And what is dry vapor and wet vapor? Dry vapor and wet vapor എന്താണ്? Okay, dry vapor is particular 100% dry vapor or dry saturation vapor. There is no wet part in this. That is at the point when the vaporization finishes. Here, എല്ലാ ലിക്വിഡും വേപ്പറായി മാറിക്കഴിഞ്ഞുള്ള that particular vapor is known as dry vapor. And when the vaporization process completed, the vapor is known as superheated or dry vapor. And when the mixture of some liquid and vapor is known as mixture of something liquid and vapor, മുഴുവനായിട്ട് മാറുന്ന സമയത്തുള്ള vapor, here vapor is known as wet vapor. Okay, wet vapor and dry vapor. And superheated vapor എന്താണ്? What is superheated vapor? When the vapor changes, when the temperature changes from a saturation temperature to superheated temperature, the vapor changes to superheated vapor. Okay, superheated vapor. That is a superheated vapor. Dry vapor, wet vapor, and superheated vapor. Superheated vapor. And last one, what is degree of superheat? Degree of superheat. So what is degree of superheat? Degree of superheat means the difference between superheated temperature and saturation temperature. Difference between superheated temperature and saturation temperature at a given pressure. At a given pressure is known as degree of superheat. That is T superheat minus T saturated. That is degree of superheat. Degree of superheat means superheated temperature minus saturation temperature. These are all the terminologies of liquid vapor interface or liquid vapor transfer. Okay. Liquid vapor terminologies or liquid vapor properties. That is superheated and saturated, wet and dry, vapor and gas, and particular critical point. Critical point. Thereafter, we want to study about PT diagram. PV diagram we have already studied. PT diagram. So PT diagram, I think you will be familiar with the diagram in your +2 chemistry or particular SLC or something like that. A PT diagram where the whole vapor, liquid and gas together occurs. Okay, together occur. ഒരുമിച്ച് വരുന്ന diagram what is called PT diagram. I think you will be familiar with that figure when I am drawing it. So please look, it's a very important figure in our particular module or particular section, that is പഠിച്ചില്ലേ PT diagram. PT diagram where whole solid, liquid and vapor together occurs. Solid here, liquid here, vapor here. Okay, and in the center point when the all three lights, there are three curves are there. Okay, this is vaporization curve, liquid vapor by മാറുന്ന curve, vaporization curve. Vaporization curve. This is sublimation curve, solid to vapor. Sublimation curve. Okay, and this is fusion curve. Fusion curve. Okay, fusion curve. And that's center point when the whole curve coincide together is known as triple point. Triple point. Triple point. Okay, the whole the sublimation curve, fusion curve, and vaporization curve together coincides at a point where known as triple point. And triple point is known as that point where all the three phases together coexist in equilibrium. Okay, that is liquid, vapor, and solid. Three phases are there, and the three phases are together coexist in equilibrium. That point is known as triple point. Okay, and what is triple point means? So PT diagram is the diagram related to particular whole three phases. Diagram relating with three phases. And the triple point is here. Triple point is point where all three phases together coexist in equilibrium. Okay, the triple point, there are something triple point data in stream table down. Triple point data is that is triple point for some particular components, substance, hydrogen, oxygen, ammonia, water, etc. So triple point ഒരു കാര്യം പറഞ്ഞാൽ ഞങ്ങൾക്ക് ഫെമിലിയർ ആയിരിക്കും. That is triple point of water. At triple point of water, when we are taking water, that at the triple point of water, the temperature is 273.16 or 273 Kelvin. I think for the first module I explained about temperature scale. Okay, and introduction of Kelvin temperature scale. That is at triple point of water, triple point of hydrogen, etc. I think we have discussed about that particular topic in first module itself. Triple point means at triple point the whole three phases together coexist in equilibrium, and at the point for water the temperature is known as 0 degrees Celsius or 273 Kelvin. 0 degrees Celsius or 273 Kelvin of water. So this is the figure that comprises the whole three phases and three curves related to solid, liquid, and vapor. And the point representing the the point represents the coexistence of solid and vapor. Solid and vapor together consist a sublimation curve. Okay. Solid, liquid, solid, vapor, ഓരോ കർവിനെ കുറിച്ച് പറയാം. Sublimation curve, or we can call it as frost line എന്ന് പറയും. Frost line, where it is the curve we will get by joining the points. By joining the points related with the relation of solid and vapor. Solid, vapor ആകുമ്പോൾ ഓരോ സ്ഥലത്തിലെ ടെമ്പറേച്ചർ ആൻഡ് പ്രഷർ. ഓക്കെ, അതായത് പ്രഷർ ആൻഡ് ടെമ്പറേച്ചർ ഉണ്ടാവുമല്ലോ. എ പെർട്ടിക്കുലർ സോളിഡ് ഈസ് ട്രാൻസ്ഫറിങ് ടു വേപ്പർ. സോളിഡ് വേപ്പർ ആവുന്ന പ്രൊസീജിയർ എടുക്കാം, സബ്ലിമേഷൻ. ഓക്കെ, ഡയറക്റ്റ് ട്രാൻസ്ഫർ ഓഫ് സോളിഡ് ആൻഡ് വേപ്പർ. ആ ഒരു ഇനീഷ്യൽ ആയിട്ട് ടെമ്പറേച്ചറും പ്രഷറും ഉണ്ടാവും. ഇനീഷ്യൽ ടെമ്പറേച്ചർ നമുക്ക് ഇനീഷ്യൽ പ്രഷർ ടെമ്പറേച്ചർ ഇസ് ദ വെൻ പ്രോസസ് ഹാപ്പനിങ്. കൂടി വരുമ്പോൾ ഒരു പ്രഷർ ടെമ്പറേച്ചർ ആവും, പ്രഷർ ടെമ്പറേച്ചർ ആൻഡ് ഫൈനൽ പോയിന്റ് ഉണ്ടാവും. ഓക്കെ, പ്രഷർ ടെമ്പറേച്ചർ ഈസ് ചേഞ്ചിങ്. So when that particular point join to form a line, that particular line is known as sublimation curve. Okay, അങ്ങനെയാണ് ഓരോ കർവ് ഉണ്ടാകുന്നത്. ഫ്രോസ്റ്റ് ലൈൻ. And second one is solid to liquid. Solid to liquid we can call it as a fusion curve. Fusion curve, or we can call it ice line. Ice line. Solid liquid transfer നടക്കുന്ന പോയിന്റുകൾ ജോയിൻ ചെയ്ത് കിട്ടുന്ന ലൈനാണ് frost line, ice line, or fusion curve എന്ന് പറയും. Okay, then next one and last one is liquid to vapor. Liquid to vapor. Liquid to vapor we can call vaporization curve. Vaporization curve is also called streamline. Streamline, that is when a particular liquid changes to vapor, pressure and temperature increases at a particular and when the particular pressure and temperature നമ്മൾ line point ഇട്ട് വെച്ച് കഴിഞ്ഞാൽ, and then we are drawing a graph, we will get a line that is known as vaporization curve, or called as streamline. Okay, this is the PT diagram. PT diagram for a substance like water. PT diagram. Okay, so for a PT diagram there is a triple point. And what is triple point? Triple point, very important term that will be asking a university question paper itself. ചോദിച്ചിട്ടുണ്ട്. And what is triple point means? Triple point is known as the particular point in PT diagram, or any diagram related to solid, liquid and phase, where the three phases together coexist in equilibrium. Together the whole coexisting system. So there are some triple point data. So the triple point data we can say for hydrogen, pressure and temperature as the for triple point data. Triple point data. Okay, for hydrogen the temperature is, pressure is 54.1 mmHg. Pressure mm of mercury. Mercury height. Temperature Kelvin. Okay, 54.1 hydrogen, 13.96 Kelvin temperature. And for water 4.58 pressure, 4.58 mm of Hg, and 273 Kelvin, or 273.16 mole fraction is the case of water. In the case of oxygen we can say that 54.36 is the pressure. 54.36 is the mmHg is the pressure, and 1.14 Kelvin. 1.14 Kelvin is the Kelvin temperature. It is the triple point data of particular hydrogen, water and oxygen. At triple point pressure is 54.1, and that is ammonia and nitrogen. Ammonia, carbon dioxide, CO2, carbon dioxide. So carbon dioxide at the pressure is 3.880 mm of Hg, and temperature is 216.55 Kelvin. Nitrogen 63.18 Kelvin, 63.18 Kelvin of temperature and 94 of Hg of pressure. Triple point data. Okay, exam ആവശ്യം ഉണ്ടാവും. Diagram may be in your data. I think it is in your steam table, right? So pressure and temperature, and when the particular it is the particular triple point data. Triple point like എത്തുമ്പോൾ ഉണ്ടാകുന്ന ഹൈഡ്രജന്റെ particular pressure temperature തന്നിട്ടുള്ളത്. Okay, that is something related to PT diagram. Okay, related to PT diagram. And next we can, and for in the PT diagram we will get a particular in the case of PT diagram, it's a very important. Okay, in the PT diagram we will get the triple point as a point. Like triple point is represented by a point. Represented by a point. Okay, in PV diagram triple point is represented by a line. It is given. Other line item PV diagram we will get is a line. Okay, and in UV diagram നമുക്ക് ആവശ്യമില്ല, ഇത്രയും P diagram PV diagram only. P diagram triple point is represented by a point, and in PV diagram we will get a particular point as a line. Okay, that is about PT diagram, and thereafter we are going to study about PT diagram, PV diagram. That is PT diagram and PV diagram, and we want to study about PVT surface. PVT surface. PVT surface, where it is the surface 3D surface which gives the relation between or the together existence of pressure, volume, and temperature. Pressure, volume, temperature. Okay, here we already studied about PV diagram and PT diagram, and thereafter PVT surface is there. PVT surface is a three-dimensional. Is given as a three-dimensional figure representing the existence of a relation between the particular component, pressure, volume, and temperature. Here the whole components are given together, given in this particular figure. The whole pressure or the existence of equilibrium are shown. All the equilibrium, like in pressure, volume, temperature, all the three phases, that is whole, liquid, and gas, all the equilibrium conditions are shown in PVT surface. So it is a three-dimensional figure. So I will draw the particular figure here. It is there in your handwritten notebook. Okay, you can draw the particular figure, and after we can discuss the particular about the PVT surface in the next session. ഒരു കട്ട് ചെയ്തെടുത്ത ഒരു സ്ക്വയറിന്റെ പീസ് പോലെയാണ്. കേർവ് ചെയ്തെടുത്ത ഒരു കാർന്നെടുത്ത ഒരു പീസ് പോലെയാണ് എക്സിസ്റ്റ് ചെയ്യുന്നത്. ഓക്കെ, this is PVT surface, that is pressure is shown here, this angle pressure, and volume is shown this side, and temperature is shown in this side. Pressure, volume, and temperature. Pressure, volume, and temperature. And here this is the region of solid. Solid is the region of vapor, and this is the region of liquid. and this is the region of solid and vapor together goes in the region of again solid plus vapor S plus V, solid plus vapor and solid and vapor ഒരുമിച്ച് മിക്സ്. Here liquid and vapor for L plus V, liquid and vapor L plus V, solid and vapor S plus V, and this is the critical point Cp, critical point I am denoting by Cp, and above Cp, above critical point the state in the liquid solid vapor, liquid already we have shown liquid solid and vapor here, and above the particular Cp value we can you will get a particular region of gas, okay, gas. So above critical point we can call the particular phase as gas. So here L plus V is there, and this line in this line L plus V and S plus V joined in the line, that particular line is known as triple point line, triple line, okay, triple point line, triple point line, triple point line, okay. So this is a figure of PVT surface. You will be asked in I think it is a very important figure. It will be asked in a series examination always, or you can ask in your university examination, right? നമ്മൾ ആദ്യത്തെ ഒരു പാർട്ട് ഫസ്റ്റ് പാർട്ട് ആദ്യത്തെ ഒരു 6 ചോദ്യം the questions will be സീരിയസ് ചോദിച്ച പോലെ 3 മാർക്കിനാണ്. അത് യൂണിവേഴ്സിറ്റി ക്വസ്റ്റൻ വരുമ്പോൾ അതിൻ്റെ അഡീഷൻസ് വരും 3 മാർക്ക്. സോ ചെറിയ മാർക്കിന് ചോദിക്കും, ഇതുപോലത്തെ കാര്യങ്ങൾ ചോദിക്കാം. PVT സർഫസ് ചോദിക്കാം, കാരണം ഫിഗർ വരക്കാനുണ്ട്, എക്സ്പ്ലെയിൻ ചെയ്യാനുണ്ട് കുറച്ച് കാര്യങ്ങൾ. സോ PVT സർഫസ് വരച്ച് പഠിക്കുക, അതായത് ഒരു പർട്ടിക്കുലർ ഒരു ഫിഗറാണ്, അതായത് സാധാരണ ക്യൂബ് പോലത്തെ ഫിഗറാണ്, ഓക്കെ, ക്യൂബ് പോലത്തെ ഫിഗറാണ്. അപ്പോൾ ഇത് നമ്മളിങ്ങനെ കാർവ് ചെയ്തെടുത്തിരിക്കുകയാണ്, ഇങ്ങനെ ഒരു ഷേപ്പ് എടുത്തിരിക്കുക, കടഞ്ഞിരിക്കുകയാണ്. അപ്പോൾ ബാക്കിയുള്ള ഷേപ്പാണിത്. അതിൽ എക്സിസ്റ്റ് ചെയ്യുന്ന കാര്യങ്ങൾ PVT സർഫസിൽ എക്സിസ്റ്റ് ചെയ്യുന്ന പ്രഷർ, വോളിയം, ടെമ്പറേച്ചർ. സോ അതിൻ്റെ ഒരു ഭാഗമാണ് ഈ കാണുന്നത്. കട്ട് ചെയ്ത് ഇതിൻ്റെ മുകളിൽ നിന്ന് കട്ട് ചെയ്ത് പോകുന്നത് വേപ്പർ, ഓക്കെ. സോ പ്ലീസ് ഡ്രോ ദ ഫിഗർ. വരച്ചു പഠിക്കാൻ തന്നെ വേണം, ആണ് വരക്കാൻ പറയുന്നത്. Then we can discuss the particular about PVT surface in next session.